In this video for lesson 7.5, we're going to be talking about 3 different theorems that relate to proportions in triangles. So the first theorem we're going to talk about is called the side splitter theorem, which says if a line is parallel to one side of the triangle, so you could see in our picture here, they're marking line MN parallel to AC. Okay, with those little arrows on the line, that means that they are parallel to each other. Okay. So if a line is parallel to one side of the triangle and intersects the other two sides, so intersect means it touches the other two sides, so at points M and N, then it divides those sides proportionally. Okay, so let me just maybe use letters here. That'll divide side AB into two parts. Let's call those sides A and B. And it'll divide line or side BC into two parts. Let's call this C and D. Okay. So if this is true, if you see the two sides are parallel, one side parallel to, in this case, like the base of that triangle, then we can set up this proportion using the side splitter theorem. So your proportion is going to be using the segments from the same side. Okay, so I would set this up as A over B and set that equal to the pieces I get from the other side, C over D. Okay, that's what this is saying right up here. They're just using the names of the sides instead. Okay, so the side splitter theorem, you can take the two pieces from one side, set them proportional to the two pieces from the other side. So let's apply this in an example and solve for x. Okay, so I'm going to be setting up a proportion here. So I'm going to get that kind of ready. So remember, our pieces come from one side. Okay, so I'm going to set this up. I always like to put my x in the first spot. So x plus 2 over 16. I just have to make sure when I do my other proportion that I go in the same order. So I kind of went bottom to top. Okay, so I'm going to go in the same order. I'm going to start with the bottom piece over the top piece. Okay, now you could also reverse these fractions. You could do 16 over x plus 2, 12 over x. Doesn't matter what order. Just make sure you're consistent when you make your second fraction. Okay, and then just like we've been doing in class, I'm going to cross multiply these. So 16 times x is 16x. I'm going to set that equal to my other cross product here. So make sure when we multiply 12 by this, we're going to multiply 12 by the entire thing. So 12 times x, but also 12 times 2. So that's plus 24. Okay, and then the rest of that is just our basic algebra. I'm going to subtract the 12x over to the left side. So that's going to give me 4x. Bring down my equal sign in the 24. Divide out the 4 on both sides, and we got our answer here. X on this one equals 6. Okay, so that is the side splitter theorem. Okay, so on the next one, I kind of covered this up a little bit on accident. I want you to go ahead and solve that. So set up a proportion to solve for x using the sides. Okay, so you're going to use this side, use those pieces, and make a fraction with that side and those two pieces. So go ahead and set up your proportion. Okay, if you did it right, here's what your proportion should look like. Okay, x over 12. Then make sure you go in the same order. So I went top over bottom, and make sure to go top over bottom again. Okay, so go ahead, cross multiply and solve this and finish this question. Okay, if you did it right, here's my work. So I cross multiplied this, and I end up getting x equals 4. Okay, so that is the side splitter theorem, using the two sides that are split into two parts and making them proportional. Okay, theorem number 2 we're going to talk about is what's called the triangle mid-segment theorem. And that theorem says if a segment joins the midpoints, okay, the midpoints of two sides of the triangle. So what that's saying is G is the midpoint of DE. So you can see here, that means it cuts it into two congruent parts. DG is congruent to GE. Okay, that also means that H is the midpoint of the other side. So you can see here, EH is congruent to HF. So you have two sets of congruent parts. So that's part of the theorem. Okay, you have your two midpoints on each side. Okay, so if this is true, then the segment that is parallel to the third side is half as long. Okay, so that means this side is twice as long as the mid segment. Remember, mid segment then is probably in the middle, right? Makes sense. Okay, so there's two ways you can kind of set up the formula. So for example, if I know that the base of this triangle is 10, the mid segment has to be half as long. It would be 5. So that would be kind of this formula. You could take half of the mid segment, okay, or half of the base is equal to the mid segment. Okay, the other way to do the question, let me maybe erase these numbers, give you a different example. If they give you the mid segment, so they say GH is 4, then I know the base of this triangle, DF, has to be twice as big. I can just double it, okay, to get the mid segment. So that's how the mid segment and that parallel side relate to each other. So let's apply this in some examples with some numbers in there, okay? So it's given that BC is the mid segment of our triangle PQR. So what we know, if this says mid segment, here are the properties that apply, okay? That means B is the midpoint of AD. So it's going to cut AD in half. Okay, so if that AB is 11, so is DB. They're congruent. Okay, this also means that C is the midpoint of AE. So again, those two segments are congruent, those little babies. Baby equals baby. So if CE is 18, so is AC. Okay, also, if BC is the mid segment, I know it's half as big as our parallel side. So it's going to be half as big as DE. Okay, so let's fill in these lines here. So if they're looking for the length of AC, well, that's right here. And when I already found it, that length is 18. Okay, number 2, they're asking for the length of AD. Well, A to D is the whole side here. So since this was the midpoint, I know each baby is 11. So 11 plus 11 makes that side 22. We're finding the entire length, not just a baby piece, the whole part. Okay. And then to find the length of BC, well, I know BC is the mid segment, so it's to be half as long as its parallel side. So half of 38, just pop that in our calculator really quick. Half of 38 is 19. So I know this side here, BC, is 19. Okay. Now the other example we can do is when we're using mid-segment to solve for x. So again, we can use either one of these formulas up here. I can either take half of the third side. Let me just erase this really quick. Okay. I can take half, okay, of that parallel side and set it equal to the mid-segment. Or I can double the mid-segment and set it equal to the parallel side. So for me, to avoid fractions, I kind of like sticking with this second option. Double the mid-segment and set it equal to its parallel side. So that means I would double the mid-segment and set it equal to its parallel side. So I would set this up like this. 2 times the mid-segment, 2x minus 5. Set that equal to its parallel side, which is 2x plus 4. Okay, the other option would be to have 2x minus 5 equal to 1/2 2x plus 4. But again, if you don't want to deal with the fractions, sometimes the numbers won't divide out nice. So to avoid that, I would just double the mid-segment. Okay, we would distribute this, so 4x minus 10, and then bring down the rest. Okay, so I'm going to go ahead and finish solving this. I'm going to subtract the 2x on both sides. So that gives me 2x here. I'm going to add the 10 to both sides. So that makes this equal to 14. Sorry about the watermark here. And then that gives me my answer here. X is 7. Okay. So that's how we can use the triangle mid-segment theorem to solve for missing sides or to solve for x to set up our equation. So on the back side of this note sheet, I want you guys to try this one. It will, because of that x squared, you will have a little factoring in there. So go ahead first, set up your equation if you know that UC, okay, is the mid-segment of that triangle. So how does that relate to that parallel side OG? Okay, here's how I would set it up. I would take my parallel side, my longer side, and set that equal to 2 times the mid segment. So 2 times 24, which then would give me this expression. Okay, I would take 2 times 24, that's 48. Since this is a quadratic, we want it equal to 0. So that gives us 2 possible solutions, x equals 8 and negative 6. Now, if you plug these answers in for x, both of them should work. Okay, you'd get 64 minus 16. That'll still be positive. This will give you 36 plus 12. So again, still both positive answers. So they both work. We would count them both as solutions. Okay, one last theorem we have to talk about is called the triangle angle bisector theorem, which says if a ray bisects an angle, so here's this ray, it's bisecting this angle, which we know means to cut it in half, okay? Then it divides the opposite side into 2 segments. So we'll have this segment and this segment. The ray bisects it, okay, and cuts that into 2 segments. Okay, then those sides are proportional to the sides of the triangle. Okay, so let me clean up this picture here, and I'll kind of go over that a little quicker. Okay, so again, I'm just going to kind of give these names. So let's call this A and B, and let's call the sides C and D. Okay, so what this theorem says, if that ray is an angle bisector of angle V, which they're showing you in the picture it is, they're using the congruent markings here, then the side the ray splits makes a proportion, okay, A over B, which is proportional to the 2 side lengths. So our sides here are C and D. But again, make sure we go in the same order. A is on the left of the ray, so it corresponds with C, that's on the left side of the ray. B over D, okay? So I'm going to do this first example, and then you'll try one, okay? So again, I'm going to set up a proportion. Because this angle is being bisected, they marked it using the congruent marks. I know that this ray, okay, is splitting that segment on the bottom into 2 proportional parts. So I can set this up, okay, using the 2 pieces from the bottom, x over 9, and set that equal to the ratio from the sides. Just making sure we go in the same order. So x would go with x plus 4 because they're on the same side of the bisector. Okay, 9 goes with 12. So I would go in the same order. X over 9 is equal to x plus 4 over 12. And like all of our other proportions, we're going to cross multiply these. So 12 times x is 12x. When I do this one, I'm going to make sure I multiply 9 by everything. So it's going to be 9x plus 36. Okay, and then the solving from the rest of this is not too bad. Just move the 9x over. So that's 3x. Bring down my equals 36. Divide out that 3, and we will get 12. Okay. Now, this next one is a little challenging. Okay. But I'm just going to give you the answer. If you want to go ahead and try it, you can. You should end up here with x equals 5. Okay. All right, so try this last one using the side split, or not the side splitter theorem, I'm sorry, the triangle angle bisector theorem. So you have these angles being bisected. So you know this ray cuts it into your 2 bottom pieces and your 2 side pieces. So go ahead and set up your proportion to solve for x on this question. Okay, here is the proportion that I made. So the two bottom pieces make a ratio, 3x minus 7 over 12. Okay, and then I set that equal to my two sides and their ratio. Again, making sure I go in the same order. So it's 3x plus 3 over 18. And just like before, we would cross multiply these. Okay, this one you had to double distribute, so it's a little longer. But here's my work for that. So I distributed. I got my x's on the left side, my variable or my constant numbers on the right side. And when we divide that out, we should get x equals 9. Okay, so this video did cover a lot of information. We had 3 different theorems. Okay, first being that side splitter theorem. So the two sides get cut into proportional parts. Okay, the triangle mid-segment. Mid-segment means it's in the middle, so it's half as big as the third side that it's parallel to. And then the ones we just did. Okay, this triangle angle bisector, which means the bisector cuts the triangle into proportional parts. So the two bottom pieces make a ratio that's proportional to the two side pieces.